So welcome to 2019 Section B Ordinary Level Technical Graphics now on question B3. So we've got a ball pond here. Okay, we'll bring up the question here now. Okay, and then we've got we have to draw an elevation direction of arrow A and a plan view projected from the elevation. So what are those views? Alright, so an elevation looking in from arrow A. Alright, this is a 3D view of the object. So this is what the elevation is going to look like. And then the plan view is looking down from the top. It's drawn directly underneath the elevation. So it's a bird's eye view. It's a bird's eye view. So you're looking right down from the top, and this is what you see. And then we will have to draw the complete surface development of the ball pond. So what's happening there is the object is being folded out. So all the faces of the ball pond, okay, all the faces are going to be folded onto one flat surface. So look, you can see the curved surface there becomes that there at the back. The side surfaces that I'll show you right now, they become here. This one here becomes that one there, the front one becomes that one there, and then the base is there. All lines on the development are a true length, so that means that they're all the real lengths, they're exact measurements. So that line there is equivalent of that. Okay, this one here is equivalent of that one there. They have to be all real lengths. So I'll begin drawing now. I'll give you a quick look at what a sample solution from the state exams looks like. So elevation plan and then the surface development there. So I'm plotting out my dimensions on the XY line. I'm marking 40 from the left and then 55 after the 40. I'm drawing vertical heights at an altitude of 35 and I'm marking 10 and 25 on it. And then I'm joining them together, so I'm setting up the outline. Okay, then that line is 40 in from the left. I'm joining those 2 points together, so that's the sloped surface. Heavy line for 10. And then the heavy line up 35, and I'm joining the top there. Okay, and then I'm going to move on to plan now. So the plan is always drawn directly underneath the elevation, so I'm dropping the points directly down. Okay, and I can go any distance down from the XY line I want unless told otherwise. I do 10 there, and then it's 80 from the 10, and then 40 from the start of the 80. So that's the center line there I'm drawing in. Okay, I'm going to heavy that line into the 40, and then I'm going to mark it in the semicircle that is a radius of 40, and then I can complete that line there. So just a reminder, if I teach you to do this sketch of what's happening in the surface development, so all the surfaces of the ball pond are being folded onto one plane or level. The dashed lines represent fold lines, the curve is divided into 60-30 and that helps to determine the circumference, and all the measurements are true lengths on the development, and they get you help you finish the final solution. So they help you get to here. So I'm bringing my lines across from elevation, I'm putting points across for the height of the curved surface. Now in plan I'm dividing the curved surface up into 60-30. The reason I'm doing that is to get an accurate distance of the circumference. So I'm going to label the points and then take the distances with my compass and plot them along that line there where my set square is. Now I'm going to mark out roughly 120 there along the XY line and draw on the center line, and that's basically so I just have enough space on the sheet there. It doesn't have to be 120, I just don't want it to overlap the plan or elevation. So I take those distances there with my compass as you see, and I step in 1, 2, 3 left and right of the center line. So they're the points on the curved surface as it's been flattened out. And I'm going to heavy the outside corners of or the outside numbers, and then I'm going to draw in light lines from the inside numbers. They are elements. Okay, they're light lines on the curved surface. Now I'm going to essentially place the plan underneath here as of essence, or the bottom surface basically. So I'm dropping down 40 there because that's the radius of the curved surface, and then I'm dropping down 55 from the 40. Look, see what I've done with my fingers? I transferred the measurements over. So I'm going to draw and make sure that that's 55 and 40. So I'm going to draw in the semicircle there, radius 40, and then I'm going to drop down with my set square in a moment. Yeah, I'm dropping down. That's a distance of 55, and it's a dashed line because it's a fold line where surfaces fold about. And then there's going to be another fold line there along the bottom. And then I'm going to plot the three side surfaces in the development. Now that's a true length there that I marked, and this is a true length where I write in TL. The heights and elevation are true lengths because the lines appear as points in plan, and if you look along the true length of a line, it projects as a point. So I took the distance of 35 with my compass, I stepped it either side there. Okay, and then I can go 10 left and right down at the bottom because they are true heights in elevation because the lines appear as points in plan. And I can join them together, and then I'm going to drop down 10 from the hidden detail line because it's the front surface we're marking in. And then that's it, really, just having in the curve there at the end. Right, cheers, thank you, bye bye.